Now, in order to make you understand the usage of time shifting property of Laplace transform, let us do these four problems. Okay, so you will be able to understand the why we are using time shifting property. All right, so let's do the first question. The first question is x of t is given by u of t minus 3. So find the Laplace transform of u of t minus 3. Okay, so as you all know, we all know the equation for u of t, the Laplace transform of u of t. It is equal to 1 by s, right? So if this is the Laplace transform of u of t, then I could say that the Laplace transform of u of t minus 3, right? U of t minus 3 is equal to e raised to minus 3s by s. Okay, the reason is because according to time shifting property, the Laplace transform of x of t minus a is equal to e raised to minus as into x of s, right? So here it is minus a, so here is also minus a. In this case, the a is equal to 3, right? Minus a is equal to minus 3. So that means whatever the Laplace transform we are getting over here, 1 by s, that is represents the x of s. So you multiply e raised to minus 3s with 1 by s. That's why you got this answer. Okay. So let's move on to the second problem. The second problem is here the given question is x of t is equal to e raised to minus 2 into t minus 5 into u of t minus 5. Okay, so here also we know the equation for e raised to the Laplace transform of e raised to minus 80 u of t, right? We know that Laplace transform of e raised to minus 80 u of t is equal to 1 by s plus a, right? 1 by s plus a. Okay, so here in this equation you should remember that the meaning of this Laplace transform of x of t minus a, if I am going to apply the time shifting property, then I have to replace every t in that equation with t minus a. That is the meaning of time shifting theorem, right? That means the signal should have all the t values should be replaced with t minus a. So that means in the given question, if you see that the Laplace transform here, the Laplace transform of e raised to minus 2t u of t is equal to 1 by s plus 2, right? We all know this equation, right? E raised to minus 2t u of t, Laplace of this is 1 by s plus 2. Okay, so now if I replace t with t minus 5 and here also t with t minus 5, then that is called as x of t minus 5, right? This means the x of t minus 5 is nothing but e raised to minus 2 of t minus 5 into u of t minus 5. This is the expression. This is what the time shifting means. That is, I am replacing every value of t with t minus 5. Okay, so because most of you will forget, sometimes you will not apply t minus 5 over here. You will simply write that e raised to minus 2 into t minus 5 into u of t. Then the time shifting theorems are complete. Here only the time shift is that. Time shifting means that in that expression every t must be shifted by minus 5 units. Okay, so this is how you should apply time shifting theorem. So according to time shifting theorem, we all know that the Laplace transform of x of t minus 5 is nothing but e raised to minus 5s into x of s, right? Here we have already found what is x of s. X of s is nothing but 1 by s plus 2, right? Because this is the Laplace transform of e raised to minus 2t u of t is 1 by s plus 2. So substitute that 1 by s plus 2, this is your final answer. That means the Laplace transform of e raised to minus 2 into t minus 5 into u of t minus 5 is equal to e raised to minus 5s by s plus 2. Okay. Now let's move on to the third question. Right. The third question states that find the Laplace transform of x of t is equal to sine t minus 4 into u of t minus 4. Okay. So let's do that question. So here the question is sine t minus 4 into u of t minus 4. Okay. So we all know that the Laplace transform of sine t into u of t. We all know the Laplace transform of sine t into u of t. This is nothing but 1 by s square plus 1, right? Yes, because ohm 0 is equal to 1, right? Ohm 0 is equal to 1. Laplace transform of sine ohm 0, this is the equation you have all studied. This is nothing but ohm 0 by s square plus ohm 0 square. So here ohm 0 is equal to 1, so 1 by s square plus 1. Okay. So now here x of t is equal to sine t into u of t. So if I write x of t minus 4, if I am time shifting the signal, then what happens is that every t, just like the last problem over here, every t that you see in this expression will be replaced with t minus 4. So this will become sine t minus 4 into u of t minus 4. Okay. So we all know that the Laplace transform of x of t minus 4 is nothing but e raised to minus 4s into x of s, right? This is your x of s. So in other words, the Laplace transform of sine t minus 4 into u of t minus 4 is equal to e raised to minus 4s by s square plus 1. See, this is how we do the problem. Okay. This is the meaning of time shifting theorem. You have to be very careful with the values of time over here. Okay. Anywhere if you see a shift that's going on like this, okay, immediately you should understand that that question is supposed to be applied with time shifting property. Okay. Time shifting property. Okay. So now let's do the next problem. The next problem, the given question is e raised to minus 5t into u of t minus u of t minus 5. Okay. So that means the question is e raised to minus 5t into u of t minus u of t minus 5. Okay. So here as you can see there is a t minus 5 over here. So while you are attempting this question itself, you should understand, you should realize that this is a time shifting property. This question is supposed to be done using time shifting property. Anywhere, even when you are doing the exam also, remember this. Anywhere if you see a time shifting, when they ask you to find the Laplace transform, you should immediately apply the time shifting property. Okay. So here I can just modify this question. Right? I can make this question into e raised to minus 5t u of t minus e raised to minus 5t u of t minus 5. Okay. So I have to apply my Laplace transform over here, and I also have to apply the Laplace transform over here. Here I know how to apply the Laplace transform. Right here we know that the Laplace transform of e raised to minus 5t u of t is equal to 1 by s plus 5. So we found the Laplace transform of the first term, 1 by s plus 5. Okay. Now let's look at the second term. Alright. The second term you are supposed to apply the time shifting property. Okay. But to apply the time shifting property, like I said, every expression in t every expression in t must be having t minus 5. So here if you see here there is no time shift applied over here. This t is multiplied by 5, but there is no expression that suggests that it's being subtracted by minus 5 units. See, that is missing over here. So you cannot apply time shifting property to the second term directly. This is where everybody makes mistakes. Everybody will just simply apply the time shifting property directly. You cannot apply the time shifting property over here directly, because this is supposed to be t minus 5, and this t must also be replaced with t minus 5. Wherever you see t should be replaced with t minus 5, then only you can apply time shifting property. Okay, so here in this second expression, okay, what I'm going to do is I'm going to make a slight change in the expression so that t minus 5 exists here and everywhere. Wherever there's t minus 5 should be there. That's how I should do this problem. Okay, so that means I can say that the second term, that is e raised to minus 5t u of t minus 5. So I want the same t minus 5 over here also, right? So in order to get that, I am saying that if I apply t minus 5 over here, this will become e raised to minus 5, replacing with this t minus 5, t minus 5 into u of t minus 5. So what do I get over here? I get here is e raised to minus 5t and e raised to minus 5t plus 25. Right, this is e raised to minus 5t plus 25. So that means I included the term e raised to plus 25 in this expression. So to make this, to cancel this, I have to multiply with e raised to minus 25. Right, if you calculate this, e raised to minus 25 into e raised to minus 5t minus 5, you will get the original question. Right, the reason I made this expression is because I want to introduce t minus 5 in the power also. Right, they should not be, the t must not be alone, it should have a t minus 5 term anywhere. Then only I can apply my time shifting theorem. Okay, so here in order to apply this is nothing but e raised to minus 5t plus 25 into u of t minus 5. Right, so since there is an extra e raised to plus 25, since there is an extra e raised to plus 25 over here, in order to compensate that, I need to add a e raised to minus 25. Okay, so now these two expressions are correct. Okay, and the advantage of this expression is that both the t is replaced with t minus 5. Okay, now I can apply my time shifting theorem to this expression. So we know that the Laplace transform of e raised to minus 5t u of t is equal to 1 by s plus 5. So likewise over here, if I apply the time shifting theorem, so here x of t is equal to e raised to minus 5t u of t, then in that case x of t minus 5 is equal to e raised to minus 5 of t minus 5 into u of t minus 5. Okay, so in that case, then the Laplace transform of e raised to minus 5t u of t minus 5 is nothing but the Laplace transform of e raised to minus 25 into e raised to minus 5 into t minus 5 into u of t minus 5. Okay, so this e raised to minus 25 is a constant. See, there is no t over here, so this is a constant, so I can take it outside. This will become e raised to minus 25 into Laplace transform of e raised to minus 5 into t minus 5 into u of t minus 5. Okay, we know that the Laplace transform of x of t minus 5, the Laplace transform of x of t minus 5 is nothing but e raised to minus 5s into x of s. This is your x of s. This is your x of s over here. So that means this is nothing but, the Laplace transform of e raised to minus 5 t minus 5 into u of t minus 5 is equal to e raised to minus 5s into, what is your x of s? X of s is s plus 5. 1 by